Okay, in this lecture we will solve a problem based on network functions. So this is the problem that is given. Let us see the example 12.9. So it is asked to determine network functions of V1 by I1, V2 by V1 and V2 by I1. So that means here V1 by I1, this is driving point impedance, and V2 by V1 is transfer voltage ratio, and V2 by I1 is transfer impedance. Fine, that means there are two transfer functions and one driving point function. So and the network given is this one. So if you see in the network, this I2 is equal to 0 is also specified. So that means it is given in the network itself. It is not like how we got it. Got the point? Fine. So for the given network now, so we need to get these three functions. So how to get? We generally need to apply basic KCL or KVLs. So we are going to apply KVL here, and before applying KVL we already know that all these functions are transform functions. That means they should be in Laplace domain. So it is like V1 of S by I1 of S. So for that purpose we need to convert the capacitors and inductors into their Laplace domain. So what happens to the 1 Henry inductor? It becomes Ls, that is 1 into S, so it is S, and this 1 Henry is becoming S again, and this 1 capacitor is becoming 1 by S because it is 1 by Cs. So you all know this, right? Right. Once you get the Laplace domain circuit, then we can directly proceed to write KVL equations, and then we can get the required ratios. Okay, so from the figure what you can say? So VB is given. So assuming that B is a node and A is a node, and A node voltage is VA, B node voltage is VB, right? So since I2 is 0 anyways, and VB and V2 are equal because there is no other element in between, so VB is equal to V2. So we got one equation here. And what is IB? IB is nothing but the current flowing from VA to VB through the element of S. Then it will be so yes, IB will be VA minus VB by S. Okay. Okay, why this is V2 by 1 by S? Because it is nothing but IB is nothing but flowing through in this. Yes or no? Because there is no current coming. So whatever is flowing here in S will also be flowing in 1 by S here. Right? So what is the voltage across 1 by S? It is V2. So IB is nothing but V2 by 1 by S. So in the end it is becoming SV2. Fine. Right. Now coming to the KVL here, VA. So that is in this loop the KVL equation is written. So it is like VA is equal to S into IB plus the voltage across this, that is VB or V2. Both are same anyways, right? So VA is equal to SIB plus V2. With that you will get this equation. So this is from the loop equation KVL, right? So yes, this is from KVL. Okay. And now what is I1? So I1 is the current flowing in this first element of inductor. So I1 will be equal to VA by 1 by S, that is this one, VA by 1 by S. So what is the current flowing here? Whatever is current flowing here, as well as plus IB. So that means here they have applied KCL. So this is from, let us note it, this is from KCL. I1 is equal to this current flowing through 1 by S and IB. So that current is nothing but VA by 1 by S plus IB. So IB we can write it like SV2, and this S VA by 1 by S is nothing but S VA. So again VA is replaced with S square plus 1 into V2, right? Fine. Now if we proceed further, what we can have, V1 is equal to that means V1. So let us apply loop equation here. So that is let us consider one loop here. So this loop equation nothing but this one, right? So this is another KVL equation. Okay, so what is that? Okay, so if you see that what is V1, V1 is equal to S into I1 plus what is the voltage across 1 by S, that is VA. Okay, so V1 is equal to SI1 plus VA. So if you simplify that, you will get this equation, right, in the end. So now we will see from all these equations, let us check for the required ratios V1 by I1. So where we can get V1 by I1? So we can get V1 by I1 from which equation, like V1 by I1. So if you see this V1, this is in terms of V2, and if you see this I1, this is also in terms of V2. So we can cancel out V2 and V2. So directly we can divide this V1 and I1. Then what do you get? S power 4 plus 3s square plus 1 divided by s cube plus 2s. Right? Fine. Then what else we need? Then it is asked to determine V2 by V1. Then we have the ratio of V2 by V1 directly here. Right? So let us give equation numbering for clarity. Okay, let us say this is equation number 1. So this is equation number 2, and this is equation number 3. Okay, so from equation 3 we can directly get this, and this we can get directly from equation 2 and 3. Fine. Then what about this one, V2 by V1? Sorry, V2 by V1 is already there. So V2 by I1 it should be. So V2 by I1. So where we can get V2 by I1? So it is like V2 by I1 will be a ratio of these two terms. Okay, if you use these two and if you divide them, what happens? Or if you multiply these two, we can get ratio of V2 by V1, that is nothing but 1 by s cube plus 2s. That's it. Okay, so this is how we need to solve the network functions ratios. So the circuit will be only one. So for the given circuit, you write the possible equations using either KCL or KVL, and with those equations, if you rearrange them, you will get the required ratios. They are very simple. You just need to apply KVL and KCL, and if you are good at applying them, you will get the answers. Otherwise it is very difficult. Fine, that's it. Thank you. And there is one mistake, you note it down. It is not I1, sorry, it is not V1, it is I1, right? It is I1. So it is a ratio of V2 by I1. I1. Fine.